So in this video, I'm going to explain the next instruction, which is called SHLD. So the name of this instruction is store H and L register direct. So their opcode will be SHLD. Their operand will be 16-bit address. And now we need to find out their size in terms of byte. So for example, let's say this instruction is written here as a SHLD 2050H. So here the function of this instruction is store H and L register direct. Direct means what? From which location we need to access that data. So that location address or memory address, their starting address must be mentioned with the instruction itself. So that is the reason here it has mentioned as a 2050H. Now we need to find out their size first. So let's say their starting address is 1000H. So at this address we are going to store their equivalent hex code for this SHLD. So as per the code given in the book, it is 22H for SHLD. Now the next location, it will be having their lower address byte, so that is here 50H, and at the next location 1002H, this will store their high order address, so that is 20H. So before execution of this instruction, it is required 3 memory location, and at one location it is storing 8 bit of data or 1 byte of data. So it is required here 3 location, it means 3 byte of data it is required to store into the memory. So the size for this instruction required to store into the memory will be 3 byte. Now we need to find out their machine cycle. So before finding this machine cycle, we must have to understand their functionality with the clarity, so that we can find out their number of machine cycle and their corresponding T state in very easy way. So here let's say this is having the memory part, and in this memory part their starting address to store this instruction is as a 1000H. At 1000H it is storing their opcode as a 22H. Then at the next location it is going to store their next byte of the address, that is called low address order or low address byte, so that is 50H. And at 1002H it will store here 20H. Up to this, like this has a storage this instruction into this memory chip. So when you will press the execute button in this microprocessor, then first of all this opcode will come from this memory to this microprocessor. This is our microprocessor. So this 22H will come to this microprocessor, and this microprocessor will execute this opcode. Then it is knowing that the further 2 location will have the address from where we need to access the data. So as a next operation, it will read this low order address as a 58, and further next order like high order address, it will read the here as a 20H. So till the time it has came this 2050H as an address to this microprocessor, and now this microprocessor will assert this to their address line as a A0 to A15, and again it will be redirected to this memory chip to access the data from this 2050H. So here this 2050H, let's say it is at this point, and 2051H is at this point. And here the operation for this instruction is store. Store means the content of HL pair which is there in this microprocessor. So whatever is the content here, so that content is going to store into this microprocessor. So by default we have to mention only their first address as a 2050H. So let's say in this L we have 20H, and in this H we have 30H. So first of all, by default low address will contain lower byte. so that this will store 20H into this location. So this 20 will be stored into the location of 2050H, and the next address will contain their higher order byte of this HL pair, so that is 30H. So 30 will store into this 2051H location. So direct means whatever memory we want to access, that address we must have to mention in SHLD instruction as like in the LHLD instruction. So the difference here is, in LHLD data was coming from memory to the HL pair. So that is the reason it was reading the data from the memory to the processor HL register pair. But in this case we are storing the content of HL pair from microprocessor to this memory chip. So that is the reason this operation, this both the operation is called here as a memory write. Memory write operation. So in this part we can write here as like at 2050H, this will be storing the first byte of this HL pair, so that is called lower byte as a 20H. So at this location it will be having 20H, and at further 2051H, this higher byte as a 30H means content of H register will be stored at this place. So here, now to count this number of machine cycle, how many times it is accessing this memory chip, so that is called here number of machine cycle. So by default we can write it here. So by default the first operation is opcode fetch operation. So here this we can write it opcode fetch operation, and this is required for T state. And further to read this 50H, it is called here memory read operation. This is called memory read operation, and for this one it is required 3 T state, and for further to reading this 20H here it is required another machine cycle, so that is also referred here as a memory read. So this will also take 3 T state. Now to store the content of HL into the memory, we are storing from processor to the memory, so that operation is called here memory write. So to store this 20H, the operation is called as a memory write operation. So this is also required 3 T state, and further to store this 30H, it is required further one more machine cycle, memory write. So this is also required 3 T state. So total number of T states here it is required as a 16 T state, and total number of machine cycle it is required here as a 5. So if we compare this SHLD with the LHLD, their operand is having the same format, their size is also same, their number of machine cycle and number of T state is also same, only the type of machine cycle here it has changed. So opcode fetch is same in the LHLD as well as in the SHLD, so that operation is common. Then the next two operation as a memory read is common to this SHLD as well as LHLD, but last two operation in LHLD it was memory read, but here in this case it is memory write. So this is the basic difference here with respect to machine cycle operation, but the number of T state it is required same in the case of LHLD as well as SHLD. So in some exam, as like in the BTech conventional exam, or sometimes in the engineering services mains exam, they might be asking to make a difference between LHLD and SHLD. Then based on this operation and data and this format, you can easily write down this and you can score your maximum marks over there. So now by this way, this is the finishing of, or this is the end of this SHLD instruction here. So I hope you understand this in the better way.